Hey, hello guys. This is Shuo Liu. I'm going to do the demo of our lab number 2 in EE 542. Alright, so before we actually begin our experiment, we have to know what we are trying to do. We're trying to create a Linux socket, so that's a communication between server and client, as you can see in the PowerPoint right here. So our aim is the node A here in this graph act as the server, and the node C and node B act as the client. As you can see, this is our topology right here, and this is the NS file that we are trying to use to build this network. So let's go to the experiment. So I'm going to swap out this one, and also I'm going to begin a new experiment. The name should be basic experiment number 2 and S2. Alright, so the description is task for experiment number 2. Alright, so after this we are going to upload the NS file that we just see before several seconds ago. I believe it's right here. Alright, so in the configurations I will select swapping immediately after all codes are running. Alright, so let's do it. So from here we will be expecting a several minute waiting, which we have already been experienced for the first lab. So before we actually while we were waiting, let's take a look of the code. This is like the enhanced version of server-side code. So as you can see, we keep the process in the while loop. So every time we can fork a new thread to handle another, like a request from the client. So this is like how we actually handle the request. We just display whatever we read in the buffer, and we use a socket FD and just send back I got your message as a response. Alright, so as you can see, this is our enhanced code. Let's go back to the log. So alright, so we will be spending like several minutes wait for this. Let's continue. As you can see, the experiment has been already successfully created. So let's go to the information of our experiment. As you can see, we have already get the network we want. So node A acts as our server, and B and C, they are clients. Alright, so let's go back to the slides, as I've already showed you guys the enhanced version of server, and which is like the main part of it. So the third part is I just copy use SCP secure copy protocol to upload our C files to the server, both the server and clients. So let's get the terminal. Right. So as you can see here, I'm just trying to access to the control server, and also I'm going to the node A. Alright, my bad. The name is changed. I think it's S2, right? Alright, it's RSA, cool. Right, as you can see, we have like client and server. Since we are trying to use A as the server, so let's compile the server file. Right, and also we just run the compiled file. So we have to as you can see here, start server on the node A, we have to specify a specific pod for the server to running on. Alright, so the server is running right now. Let's go to the client. Since we have like, right. So let's access to the node B and node C. So, alright, so we are running on the node B. Let's see, cool. So we have this client. Alright, so as you can see, the enhanced version of the client is meant for the last 2 pages of my slides. So for now, let's just use the default one, which are provided by the professor. Right, so as you can see there, client.c. Let's check if this is like the default one. Nope, this is not. This is the one that I made some changes. Let's how can I fix this? Alright, so let's do that again. Right, so those 4 lines that has been commented out on the previous one. So right, let's right. I will explain the codes when we trying to explain the last 2 pages of my slides. For now, I'm going to restore this to the default version of it. So which means we will give like 2 parameters right here. Yeah, right. This is another one. Right. Some just slight changes. Alright, so I'm pretty sure this is what the default version looks like. I'm going to save. Alright, so let's compile this client.c. Okay, seems like there's a small typo out there. Let's fix it. So we lost a. Alright, I think this should work. Cool, it works. And so yeah, first of all, we have to specify the address of the server. For now, our server is like the address of node A. Cool, I got you. So this is the node A. Also, we have to specify the pod as well is 1, 2, 3, 4, 5. Alright. So as you can see here, let's do it. Shuo is grading from node B. As you can see here. So in the server this is already been the enhanced version, so you can handle multiple requests and without ending the program. Cool. Let's do that again. And also I'm going to do it here. Nice. And I'm going to SSH to the node C as well. Alright. Yeah. Cool. So right, we'll just let's compile this. Okay, so the same command. Alright, so Shuo from node B, Shuo from node C. As you can see right here, got this. Feels good? Cool. So, right, this is like making start client, making request from client B and client C. Right, so that's when we can, that's the part of it that shows us the capability of this code to handle multiple clients, multiple requests as well. So, but we also really care of simultaneously requests, right? But I mean, since we are really, everything is based on Turing machine, so there's like nothing like 100% at the same time, right? But I mean, we also, the ones we care is like one client use like 2 threads to make 2 requests at the same time. That's something that we should really care about. So this is where I changed the code, so we don't need to like input some like another step to input some message. Just use this short greeting as the default one. So just everything is one line. This request is made just one line. So that's when we can make like two thread to make 2 requests. Alright, so as you can see, let's go to the terminal. So I'm going to use node B as the client who just used 2 threads. Cool. Alright, so let's compile the right. So yeah, now we only care about the address of the server and also the pod as well. Right. Let's go back. As you can see right here. So we use the hyphen and to fork 2 thread. As you can see right here, how this works is like we just put one of them in the background, so we just running 2 of them at the same time. As you can see from the server, we got all those two requests here. So as I said in the slice. So we show that our code has the capability to handle multiple simultaneously requests. Thank you. That is basically the demonstration of Lab 2. Thank you for watching.